Quick question before we get going. Can everybody hear me? Somebody could just pop a question in or pop their hand up. Excellent, good. Right, so we'll kick off. This morning's webinar is on SolidWorks equations. We have previously had a webinar which has looked at equations and talked about intelligent modeling, which was done by Adam Rose a little while ago. What I'm going to do is I'm going to cover some areas that were sort of touched upon but not necessarily covered in more detail at that point. So without further ado, and as my presentation has decided it wants to go to sleep, let's jump into SolidWorks. So a very simple model, as you can see on the screen. Equations are all about getting information from one area of your model to another area of your model, or one area of your file to another area of your file, and driving stuff without you having to manage it individually every time. So what we're going to be doing is we're just going to have a quick flick through about where you can pull information from when you're doing equations. So in the equations editor, we can either make it always visible on a tree, or it's visible after we've added an equation, or we can get it via the tools equations. So how do you build equations? Well, the simplest way to build an equation is if I double click on a dimension, I can type in, say, 210 plus 40. And this is what I call a one-off equation, or getting SolidWorks to do the maths for you. So if I type in 210 plus 40, I hit return, I get 250. Now, when I double click on it, you'll notice I've only got a single value. It hasn't remembered the equation for me, hence why we call it a one-off equation. Something to note, when we're doing equations like this, we can put in multiple units. So if I put in 210 millimeters plus 10 inches, SolidWorks will do the maths for me, and I get 464. It will automatically convert all units to your current unit scheme and then display the answer. Again, if I come in though, we don't have my equation. So if you want to remember where you got your equations from, what you need to do is you need to put an equal sign in. So if I put equals 210 plus 40, to go back to my 250 value, hit that, you'll notice straight away we get our equation symbol appear here. And when I hit the tick, I get 250 and I get my equation warning. Now that means when I come back to it, I will still have the equation. And if we come through here, in my equations editor, my equation is filled in for me. So it's actually created it as an equation. So the difference between doing what I call a one-off equation is the equals. If I delete the equals, hit return, we've got a number and no equation again. So it's just something to remember. We've got very quick edit functions where rather than you having to do the maths when somebody comes in and says make this 15 mil longer, you can literally come in and say make this 15 mil longer and let SolidWorks do the maths. Whereas if we want to make it a full equation, I need to remember my equal sign, and we get our full equation. So it's just a point to note, we've got to make sure that if we want equations rather than the one-off maths, for want of a better term, we need to use that equal sign. So we now have a real equation and it's listed in our equations editor. If I come into my equations editor, we've got three sections as Adam previously described. Our global variables, these are numbers that we want to make use of, or calculations which we've done, which we want to sort of have an answer to, but we're not using that answer necessarily anywhere directly. So these are static variables that don't necessarily influence the model, but I can use them later on to influence the model. Where can we get global variables from? So if I give my global variable a name, I'm not going to be very original because there's going to be quite a few of these. So I've called it my global variable, and pressing tab to move into the next box is now saying what do you want the global variable to be. So these can be static numbers, and then hit the tick. Static number, so this might be where you want your global variable static number, which is nice and obvious, and you're going to drive everything from this static number. Why do I say it's going to be nice and obvious? When I hit OK, I can expand my equations box and I can see my global variable listed. So right at the top of your feature tree, you can see that driving number if you're going to use that number to drive everything later on. So what else can they be? They can be static values. Well, we can also drive them from dimensions. So I can say my global variable equals my dimension, D3 at sketch 1. Again, it's going to be now equal to 250. Why is this useful? Well, you might say I'm going to create a number of global variables which have got specific names driven from individual dimensions. We're then going to do some calculations on my global variables, and we're then going to push that into into something else later on in our model. As well as being able to pick up dimensions and having static values, we can link these to an external file. But this is basically just a text file with values in it. Adam went into quite a lot of detail that in the previous webinar, so I'm just going to say you can do it. It is just a text file. As of 2013, when you do a pack and go, that external file gets taken with the model, so it's something which is being fixed. But I'm not going to create one if it doesn't make sense. We can also pick up custom properties. Now, why would that might be handy? Well, custom properties you can do a whole load with, and a lot of people are used to going into the custom properties and setting values. And displaying those values later on in the drawing, or grabbing hold of custom property values and using them in macros and that sort of thing. So how do we get hold of custom properties? Well, we can start typing it in, put speech marks and go, I think I called it my property. We'll find out in a second. No, clearly I didn't. So we can type the name in, or we can come down. We got file properties. Oh, my number, not my property. Careless of me. So I've got two here. I've got my number and my other number. Now, why have I got these listed differently? I'll show you in just a second. But essentially, we type it, or select it, hit the tick, and it will fill it. When I hit the tick, it'll update. We've got 10. Now, why did I have my number and my other number? Well, if I jump out of here and we come to my custom properties, we can see I've got my number, my other number, and my word, and those were the three properties I've got created. Now, I couldn't see my word because it doesn't evaluate to a number, and everything in the equation has to evaluate to a number. So my word isn't given to me as an option. However, my number and my other number both were when they evaluated 10 and 100, even though they weren't both of type number. So if you are going to link to custom properties, you don't have to make sure you make them all numbers in your custom property dialog, although that might be tidier. As long as they evaluate to a number, you're good to go. Okay, so that's why I was just saying those two. So what we're going to do now is we're going to jump in and we're going to start doing some stuff with this model to make it a bit more intelligent and start building up some equations. So if I jump back into my equations editor, what we want this model to do is, as I make it bigger and smaller, I want to increase the number of cross members. This is a very common problem that a lot of people ask us about, which is why we're going to be looking at it today. So the first thing I want to do is I have set with this equation that this is going to be equal to 250. Now this could be a static value. I could also make it a global variable. So if I said my global variable is going to equal 250, I can then say that this dimension is going to link up to my global variable. Oh, make sure I delete what's there, and we're going to pick up our global variables. Now, a lot of people find it annoying to go across the box, making sure to stay in the right row and click on things. If you start typing, it will start shortening the available options list to be the things that start with your typing. So I've typed my, and you can see I've got my number, my other number, and my global variable. Now I'm going to pick my global variable. And so we now made sure that this is equal to 250. And I've got a warning, right? I need to tick that box. I'll come to that box in just a second. We now want to make sure that this gap is replicated into here as well. So what we can now say is we want this dimension, if I click in the box there, we want that dimension to also, oh, no other equals, also be equal to my global variable. So now we've made sure that not only the gap to the first cross member, but then the gap between the cross members are going to be the same value. And it's it will be a nice easy to see value up here. Now this is still saying 10 because I haven't exited the equations dialog to allow this to update. So now we need to make sure we've got enough of them. So this is a pattern, linear pattern 1, And hidden behind here, we have the instance count. So what I want to do now is I want to take the instance count, and I want to control how many instances there are. So this is going to be my overall length divided by my global variable, or I could divide it by the pattern gap just to keep things a little bit easier to understand. And that's going to give me the right number. Yeah. So as I hit the tick here, we've got 3. 800 divided by 250 equals 3. So that's very nice. Now, something which we've discussed in previous webinars is what the different orders are. If I come and have a look at my ordered view, we can have a look at why I'm getting this error message. At the moment, I'm saying that my sketch is equal to my global variable, but I haven't actually said what my global variable equals until the next line, because this is the order it's going to do the equations in. Now, SolidWorks has got automatic solve order as an option down here at the bottom. If I tick automatic solve order, it will rearrange your equations so they solve in one rebuild. Otherwise, you might potentially have to do 2 rebuilds in order to see the updates. The first rebuild would set D3 here to whatever value it was before, because it can't see an answer for my global variable. Then we'd have set updated my global variable, and the next rebuild would then have corrected it. So if you edited the global variable, you'd previously have required 2 rebuilds. Hitting the tick allows SolidWorks to work that out for you, basically. So we now are setting this up. When I hit OK, everything will rebuild as soon as we make the change. If I don't want to leave the equations editor and see the rebuild, I can hit rebuild. So we'll do that, and straight away you can see we get our extra cross member in. What I'm going to do now is, so this looks good. Every time this gets longer, we will get this dividing up. So if I hit OK on that, and we turn Instant 3D on, just so I can drag my dimension around. As I drag this down, we will see that cross member disappear, but we don't. Now, the reason we're not seeing that is if I come back to my equations editor, all I've said is that this has got to be equal to 3. Now, that's coming out as a round number. Obviously, 680 divided by 250 isn't a round number. So if we create a global variable, and we're just going to call this one test, what we're going to do is we're going to have exactly the same equation. And I was picking that one, wasn't I? And hit the tick. Now, this one, because it's not an instance count, which is what D1 at pattern is, which is our instance count here, it doesn't need to be a round number, whereas the instance count does. So we can see instantly that this is 2.72, and SolidWorks is rounding it up to 3, the nearest whole number, because this needs, an instance count obviously needs to be a whole number. So we need to try and fix that. Well, there's something that SolidWorks, a function SolidWorks has got called, which, if I have a look in this list, is called int down here. Now what this means is it's going to make everything an integer. Otherwise, I suppose the other thing you could call it is round down, for want of an easier way to explain it. So if I choose int, it's going to put both brackets in, so I'm only going to delete the back bracket and then put it on the other end. And I hit the tick. We're now getting 2 rather than 3. So 2.72 rounded down gives me 2 rather than rounding up to 3. And we now have a rebuild, and we can see it gets rid of the extra one. So if I come back into my model, click on the sketch, when I drag it, it will be 3. When I pass 750, we will get 3. So you see the third one appearing there as I pass the 750. But when I would be 3.5, or above 3.5, sorry, I stay at 3 until I get 4. We just see that appearing before my mouse disappears off the screen. So using the integer command, we get a better response, or a response closer to what we were expecting than we do without it. So that's the integer command. Now, we want to have a look at some of those other commands. So if I start a global variable, as I said before, I'm not being too original with these names. I've got a lot of them to to look at. So there's some other things in our functions, and these are essentially using functions that SolidWorks is going to do the maths for you rather than you having to type it all out. So we've got some fairly standard ones: sine, cosine, tangent, secant. cosecant, cotangent, arcsine, arccos. So these are all pretty normal. And then we've got, these are all to do with angular calculations for those who don't recognize the words. We've then got some sort of more generic ones, I suppose. We've got absolute. What that does is that will take an equation that would be negative and it just makes it positive. So if your equation can equal -1, you put absolute in and it will do the equation. It will give an answer of 1 rather than -1. So to give an example, if I do absolute of 50 times -1, it equals 50. Whereas if I take the absolute away, that will come out at -50. So absolute basically just makes everything positive. Now this can be quite handy if you have any equation which could give a positive or negative answer. So for example, a quadratic equation, then it always gives a positive answer coming out. The reason you might want a positive answer, if you're controlling a dimension, dimensions cannot be negative. So it will give you all sorts of errors if you try and make a dimension come out to a negative number and not allow you to use the equation. Absolute then means it makes it positive, and so allows your answer to be true in both cases potentially. Next variable, and let's at least get my spelling right, even if the names aren't interesting. We then have exponential, so you can give your exponential values to your equation. We then have log values, so if you're looking at logs in your equations. SQR is square root, so that's nice and easy. Integer, which we've already covered down here. And then we've then got if. Now if is particularly interesting. So if gives you the flexibility to do a whole load of stuff. So we've had a quick look at this model. What I'm going to do is I'm going to very quickly jump into another file and have a look at this frame. So this frame is controlled. We've got a width and a height, and then the thin feature extrude. The width of the thin feature is controlled by an equation. So as this, if I keep that, if that stays at 250, as I make this bigger or smaller, so if I make that 200, we're keeping this the same. If this comes down to 200, I've just got to remember what numbers I put in. You can see my thickness is now 10, and because we're changing the various dimensions. So if I come into the equations dialog, I have an if statement. So if D2 at sketch 1 is greater than 200, which is this file, and if it's greater than, and if D1 at sketch 1 is greater than 150, then we should be 20. So if I make this greater than 200, so make that 250, and we go for a rebuild, we've got greater than 200. Let me get my equation back up. We've got greater than 200, so this if statement is true, which means we look straight after the comma. If D1 at sketch 1 is greater than 150, that is also true, so we look straight after the comma. We've got 20. Else we can have 15 if we are greater than 200, and otherwise we go all the way back to 10. Now, that seems very confusing because I have a nested if statement. If we make this a little bit simpler and just have a single if statement, it becomes a little bit clearer how that's working. So if this comes down to less than 500, I might want to get rid of my pattern. Now actually I'm controlling my instance count so it disappears, but what's happening is the linear pattern is erroring. Yeah, erroring. Not particularly nice. So what I'm going to do is when it comes down below 500, I'm going to turn it off. Now this is an if statement. So if I come back in and manage my equations, because I'm controlling a feature, not a dimension, I'm clicking the features box. And what I'm going to say is if this dimension is less than 500, in fact less than or equals to 500, because both would be true, then, so what happens is I've written my condition in, dimension to a particular value or compared to a particular value, then if that's true, we're going to suppress it. Now, to suppress it, I just need to type SU because we're going to type in the whole of suppress and choose it off the list. Else, and then what happens is we're going to choose UN because I can't be bothered to go and find it in the menus, and we're going to choose unsuppress and then close my brackets. So if a condition is true or it's not true. So this bit is my condition, the first section, and so I'm saying if that condition is true, then do this bit, otherwise do that bit. So if condition, comma, true, comma, false is the easiest way for me to sort of pronounce it. And in this case, my dimension is 566, so it is greater than 500. So we look after the first comma. Sorry, no, it's greater than 500, so it's not true. So we skip the bit after the first comma and we look after the second comma, unsuppressed, evaluates to unsuppressed, which is exactly what we'd expect. If I take this and again we shrink this down to under 500, so let's just drag it to here. Give that a rebuild. That's interesting. What have I broken? I selected entirely the wrong feature to suppress. That would do it. Right, it's entirely my fault. So if I copy that equation and this time we select the right feature and I put the same equation back in, single equals, and hit the tick, it's coming out as suppressed, give a rebuild, and it will go away. So if the person doing the demonstration clicks on the right buttons, we get the right answer. So what I'm going to do there is if I rebuild that, right, we should get our trim extend back. I need to unsuppress it. There we go. So now at 490, my linear pattern is suppressed. As I drag it back past 490, or back, sorry, past 500, you can see straight away the linear pattern unsuppresses. Now, in some ways, it wouldn't matter one way or the other, but it does mean that our feature tree stays from going red. So this is a nice simple if equation. There is no reason if equations have to be limited to features and suppression. You can say if this dimension is greater than 500, then I want the width to be greater than, I want the width to be 600. If it's less than 500, I want the width to be 400. In fact, let's do that as a nice example. So we'll take that and then we're going to say if the overall length is greater than 500, we're going to have a width of 600. If it's less than 500, or 500 exactly in this case, we're going to have a width of 450. Ooh, 450. Now the reason I'm choosing two different numbers is just so we can guarantee to see this change. At the moment we are greater than 500. So if I hit rebuild, we expect this to change to 600. It's going to remove my equation. That wasn't very helpful of it. And the reason it did that is because I forgot to hit the equals box. The tick. There we go. So equating to 600, if we do a rebuild, we'll now see that change to 600. If I come out of here and adjust this to lower than 500, we should see that update to 450. It does require me to stop using Instant 3D so that it can actually rebuild that length. So I have to actually let go of the mouse button and stop Instant 3D in order for the actual rebuild to take effect, but we can see the number changing straight away. So these are very nice simple if equations. But as I was trying to show you in the other file, your if equations can get a lot more complicated. You can start nesting your if equations where you have an if inside an if. The sharp-eyed among you might notice that in this equation I've actually got a double I rather than a single I. Between 2011 and 2012-13, SolidWorks prevented the use of all forms of VBA in equations. So that isn't there. You'll see a lot of stuff on the forums about people moaning about that. However, in 2013, the if statement, if you want to do nested if statements, then you will need to use the VBA form of if, which is if, rather than the SolidWorks form of if. It's a known bug at the moment, but it's just an extra character, and then it will work correctly. Otherwise, it will complain the syntax is incorrect. So nested if statements are still perfectly possible. Just remember to use the extra I for if. So that's a more complex if statement. What we're going to have a look at now is some other very common requests people have. So I've got two linear patterns here. This is I've called linear holes. What this does is it's got some equations inside it to rebuild so that the number of holes always fits as many as possible into the length of our bar without ever cutting through the end. But it has a set distance for the holes offset. So what I've done here, just to make it a little bit easier to read, is I've taken all of my various sketch entities and put them into global variables. Then I've had a global variable calculate the number of holes, and it comes out as 8 millimeters rather than just 8. And then I've used that global variable to drive the pattern, just because it's a little bit easier for me to read through. So I've calculated the length as being my overall sketch length. I've then got a start offset. Now the start offset is the distance to my first hole, 15 mil. I then have a holes offset. So if I look in the linear pattern, I've got a gap between my holes of 30 mil. And what I've done is I've said the length minus 2 offsets, because I want to have a minimum of that 15 mil offset, to calculate the length I'm going to put holes in, divided by the number of holes, 30. And then I've added +1, because otherwise I won't calculate an extra gap, basically. And then I've said it's going to be an integer, so I round down so that I don't get that problem we saw with the weldment where I get an extra bar. So when I hit OK on this, what I can do is when we change this up, if I go 250, 260, and give it a rebuild, we've got a nice large gap because we can't quite fit a whole hole in. When I go to 270 and rebuild, we now get an extra one, and this is the minimum gap. And in fact, we can check that if I have a look at those two and we measure it, we have a distance of 15, which is the minimum offset. So if I make this 1 millimeter shorter, that hole will disappear and we get left with a gap again. So it's the maximum number of holes I can, or holes I can punch into it without cutting through. So this is calculating the number of holes for me dependent on a specified gap. The other way around, a lot of people want to look at this very similar problem, is where I know how many holes I want to have in something, but I don't know what spacing I want to be putting between them. So this is the other way around, laid out in the same way. I know what my length is, I know how many holes I want, in this case 8. I know what my start offset is, so this is the offset to the first hole and the gap required for the last hole. So what is the gap I want between things? So we start by calculating the length we're working with, as before, which is length minus start offset by 2. So up to this point, very similar equation. But now what we're going to do is divide it by the number of holes minus 1. The reason we do the number of holes minus 1, and the same reason we get the +1 in the previous equation, is because we're looking at the gaps, not the number of holes. So we're going to have a hole on this end, a hole on that end, and then a number of gaps between them. So we want to calculate the gaps, so we take a hole off. And then I set it to custom offsets. Now, this is quite nice and quite friendly, because again, if I change 300 and I change it down to 250, it will bring all of my holes together. So I know very simply what my hole is, or number of holes are going in, and it becomes very easy to modify and make sure my gaps are all equal, all even, all the time. So it becomes really handy. And if I want to make it a little bit more difficult for myself, what I'm going to do is I'm going to make it a bit longer so it's easier to fit everything in. Oh, no, 350, that's the button I'm looking for. So we get a nice big spacing. You can then say, well, actually, I want to change the instance count of my holes. I'm going to make that 10 now. Give it a rebuild, and the equation is still valid. All that's happened is my hole count has gone up before it's been plugged into the equation to calculate the gaps. Yep. Now this can be used along with the assembly feature, feature-driven component pattern to make balustrades really easy to calculate. So this is the same part in the bottom, controlling the spacing, and I've just stuck a very simple rod in it. If I change this dimension up, the assembly will cope with all of those changes. So it's very quick to keep all of my changes, all my assembly building working the same way, and control all the spacing very quickly. So that's some really useful examples on using the if statement and the equations to drive things. What I've also got here, oh no, I want to stay in my recent documents, is I've also got some stuff you can do with equations. Now, this is a very simple square block, but the equations here require that I turn off that message because I'm driving circular references in here. Now, you can drive circular equations, circular references in equations, and in this case, my two equations, my two dimensions keep referencing each other. And it's just so it doesn't matter which way around, they'll always reference each other, sort of not randomly, but one will update, then the next one will update, and so on backwards and forwards. So there is definitely a circular reference going on, and each time I rebuild this model, the size will change. So as I go rebuild, 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 the circular equation is taking effect. Now, in this case, it's giving a nice pattern, which could be used potentially in an animation, for example. But really, this is just to show the risk of circular references and why you should try not to have them in most cases in equations. But it's also to show why the rebuild order is important, because if the rebuild order went the other way, you might find that these two equations didn't work, because they'd be trying to build the wrong order, so the first thing would update and we might get to a solution where there's only one possible answer rather than the continual change. So you can do a lot of things with equations. They become really handy. As you start to use nested ifs, you get a lot of power. You can drive you can control the size and shape of a part very accurately. So that's equations. There's a lot going on in equations. I suppose really now is, do you guys have any questions? Have you got any anything which you've wanted to do potentially? Right, I've got one question here about deleting features that contain equations. The reason you have to go back into the equation editor is they potentially could drive more than one item. So it's forcing you to go back into the equation editor so that you, I suppose, to fix everything. Because if that feature is in multiple equations, you may not have realized it's in multiple equations when you did it. So it's forcing you to go into the equation editor to check that all of those equations are still required, and to update them. So if for example we've got our linear pattern controlling a whole load of equations and is controlling all sorts of different bits and pieces, we might find that we wanted to update just one of those equations with a different feature, so it doesn't delete the equation for you. I hope that makes sense. If it doesn't, then email me and I will. I'll give you a better answer, or try and give you a written answer, if that makes sense. Right, there's a few questions. You just bear with me while I go through them. You shouldn't find it as long as you can find the actual. Sorry, I had a question about selecting instances. As long as you can find the instance itself, clicking on the instance should bring it through. The other thing you can do is, if you are struggling to pick up by clicking on instance counts tend to be the first dimension in your linear pattern. So this is my instance count here. That's there become the first dimension. So if you can't click on it, as long as you know the name of your linear pattern, D1 at linear pattern name is the other way of getting it. You can always type the name in. So I've been pretty lazy in some of these. So if I take this one as an example, I've been pretty lazy and I do like shortcuts. So I've been clicking on stuff to select it. And you can click on anything in the left-hand column to select it to pop into the right. But you can always type it in. So like this one. Of course, this does involve you spelling things correctly, something which I have to confess I often have a problem with. But yeah, as long as you can see the instance count, you should be able to click on it. If you are struggling, D1 at linear pattern name should sort you out. Right, next person. That's a really good question, Matthew. What happens is we've questioned, can you use a global variable in an assembly, in parts in that assembly? Yes, you can, Matthew. Yeah, if you've got a global variable in the assembly, as long as you're using edit in context on the parts, then you can control multiple parts. So if I jump into my assembly, oh, no, help if I click on the right box, and we say length 200, so just to very quickly create a global variable. If I then edit this in context, so I'm editing it within the context of the assembly, then we can come back in, help if I clicked on the right button, we can go, let me get my brain in order. So you can see here I've picked up length at balustrade. So if I'd done that on the other side, which is what I meant to click if I'm honest, we can pick this item and say we want that dimension, and we can say it equals length at balustrade. Does that explain how to get there? It doesn't necessarily appear in the various equations dialog, but we've got that length at balustrade which we can reference. And then these get shorter. So as I edit this global variable, so if I make that 300 again and hit OK, my rods get longer because they're being driven by the value at the top level. Hope that explains that one. Right. We've got a question about covering any other statements in VBA. Historically, you could put any VBA statement that's solved in a single line into equations. They have changed the way SolidWorks reads syntax, and now it doesn't work that way. Unfortunately, if is still valid, but that is the only VBA statement that is valid where the syntax solves correctly. There are a couple of guys on the forum who have been trying some ways of getting syntax in, or VBA syntax into the equations, it's sort of shoehorning it in and ignoring errors. I have tried it myself and not had much luck. So at the moment, if you just stick to if as the way of as the only VBA statement that works in equations, you're going to be safe. Everything else, you're certainly going further than the functionality is intended to go, and I would expect it to fail, I'm afraid. Any other questions? Excellent, guys. I hope you enjoyed that. I hope you learned something from it. Looking forwards, as usual, we've got some more webinars coming up. Next week, we've got Advanced 3D Sketching, and the week after, we've got Sweeps and Loft. As always, if you think of any questions going forward, then there's the number on the bottom of the slide there, and you can always email me. I'll be happy to send you some examples. Likewise, if you want any more example files, which are pretty simple, but just to show you the sort of concepts, then feel free to pop me an email and I can send them over to you. That's not a problem at all. If you want to refer back to this in the future, it will be going up on the website and onto YouTube at some point when I get round to tweaking and tidying up the recording. Thanks very much, guys. Cheers. Bye-bye.